Good evening, ladies and gentlemen. Now, shall we start? Dr. Chen?
Yeah, yes, please.
Okay, this meeting will start now. Good morning, good afternoon, and good evening. Whichever time it's where you are, I'm Suli, the Vice Director, National Institute of Paris Disease, China CDC. Today, I'm very glad to moderate the fifth idea forum, Lessons from Authors, held by the General Infectious Disease Authority. Firstly, let's welcome Dr. Dirk Ingels to give us an opening remark. Dr. Dirk Ingels was the former director of the NTD Control Department at WHO. He has a great amount of experience and wisdom in the field of tropical disease. Now, he is a global health consultant. He also is senior advisor for Uniting to Combat NTDs and adjunct professor at National Institute of Parasite Disease, China CDC. He has made many outstanding contributions during his tenure at WHO, including his contribution to the design of the WHO's novel and comprehensive strategy for the control of NTDs, development of norms and standards for the implementation of the integrated large-scale preventive treatment interventions for 5 NTDs. As director of the Department of Control of NTD, steering of the global expansion of interventions for the control and elimination of NTDs, including of NTDs in SDG framework. So, Dr. Ingels, please.
Thank you, Dr. Lee. And, I would like to add to that I'm also Deputy Editor-in-Chief of Infectious Diseases of Poverty and a guest editor of the thematic series on economic impacts of infectious diseases of poverty. And that brings us to this session of the 5th idea forum, actually. Why am I involved in infectious diseases of poverty? Well, I believe I have good reasons to do so. First of all, because I believe in the journal and the specific focus it has managed to generate as a relatively recently created global health journal. And then the second reason is because I'm a keen supporter of these thematic series, both within infectious diseases of poverty and across the journals in the same group. And as such, with Professor Zhou, we had this idea of creating or launching a thematic series on economic impacts of infectious diseases of poverty. We indeed use a lot the link between poverty and disease in our advocacy. And although that is quite intuitive and people have seen that in practice, people who have worked on neglected tropical diseases in the field, these days, you're only credible when you come up with hard figures. So that is also the reason why we launched this thematic series. So the idea is to solicit articles specifically documenting this relationship, the economic impact, relationship between disease and poverty, hoping that one day we will have enough papers to do a review and come up with solid figures, global figures on impact and economic gains that are to be made by controlling these diseases. The series currently contains 7 contributions, I believe. And the article that is going to be presented today in this 5th idea forum is probably the one that goes most in depth in terms of analysis of the economic impact of a disease. And the disease is schistosomiasis. Now, schistosomiasis is one of the more complex neglected tropical diseases, not easy to study. And I know that very well because that is also the disease I have worked most on in my early career, before I actually started dealing with more diseases as I moved up the ladder in WHO. So in a few minutes, Dr. Daniele Rinaldo will present the study design, the data analysis, and I also hope the conclusions of this study that are quite important and confirm what we intuitively suspected, actually. And as he also states in the paper, this study provides a methodology that could be extended to other studies for different diseases and in different settings. So I also hope he will expand a bit on that potential, because that could trigger off similar studies that would further enrich this thematic series. Now, before handing back to you, Dr. Lee, I would like to address a few words to Dr. Rinaldo directly, and especially congratulate him for a great piece of work. And I would like to ask the audience to be very attentive, to enjoy the talk and draw some inspiration from this study for further studies in other disease areas. So I thank you.
Okay, thank you very much, Professor Dirk Engels. Just as Professor Engels mentioned, this is the fifth session of the forum, and he gave us a very brief introduction about this forum, on the objective and contents and the articles will Dr. Daniel will give us the presentation. So firstly, let me introduce the Dr. Daniel Rinaldo. Dr. Daniel Rinaldo is an associate professor in the Department of Economic and at the Land, Environment and Economic Policy Institute at the University of Exeter. He completed his PhD in economics at the Graduate Institute of the International and Development Studies in Geneva. His research lies at the nexus of the environmental development and mathematical economic. His current applied research studies the economic impact of the endemic disease, with a focus on the sub-Saharan Africa. At the same time, he is a classical pianist. Many studies have shown that learning a musical instrument helps improve thinking efficiency, and I believe Dr. Daniel Rinaldo's story increased the credibility of these studies. Recently, his paper published at Journal of the Disease of Poverty has been widely discussed on the Twitter and other social media. He provides a unique perspective on the connections between the schistosomiasis, socio-economic and environmental variables. So, Dr. Daniel Rinaldo, please.
Hello, everyone. Thank you so much, Dr. Lee, for your words. Thank you, Dr. Engels, for your introduction. And thank you also for completely understanding the point of this paper, which is to really try to mix together. Can you see the screen?
Yeah.
All right. To really understand what the point of this work, which is the output of our research project that came during the last 2 years, which I was leading, which is to really join different disciplines to understand the complexity between the mechanisms that connect the economic world, so society and infectious diseases, in particular, the economic impact of schistosomiasis. So thank you again very much for your words. I will jump straight into this. So good morning, good evening, depending where you are. I will present the paper which has just come out on infectious diseases of poverty, called The Economic Impact of Schistosomiasis, which is in collaboration with my wonderful co-authors, which is a heterogeneous bunch. Me and Jean-Louis are economists, Javier is ecologist, epidemiologist, and Jörg Gutzinger and Penelope Bonazzo are prominent epidemiologists at the Swiss Tropical and Public Health Institute in Basel. So we each bring our expertises into studying this interesting and complex phenomenon, which is the economic impact of schistosomiasis. A couple of, where's this? Okay. Just one slide to put the paper into perspective. We don't need to sort of convince everyone nowadays of how economic systems can be made vulnerable to diseases. I mean, the current pandemic has shown this quite dramatically. And in particular, though, what we want to study is the impact and the effect of the so-called endemic states, which is when a disease is both widespread and persistent in a system. This is mostly concentrated in developing countries, but not entirely. So in the most general of senses, what we want to study is, first of all, the economic consequences of the endemic states and how can one identify their burden. Dr. Engels has pointed out very correctly in the introduction that these are complex phenomena which have a lot of interacting effects, a lot of contrasting effects sometimes, and really to identify and to isolate the effect of one is by no means a simple task. So in particular, we are interested in studying the feedback effects, so the back and forth mechanisms and dynamics which are generated between economic development, the environment, and diseases. Of course, this is very general. We'll be more specific than that. And in this paper, we focus on schistosomiasis, which is a bilharzia. So this is a waterborne neglected tropical disease, which is chronic and debilitating. It's a parasitical disease. And one thing which will be important, which I will explain this in detail later on, is that the host which connects the parasite to the humans are aquatic snails, and humans get infected by a water contact. So our goals in this paper, first of all, is to identify and estimate the economic burden of the disease with an empirical focus on Burkina Faso. We focus on one country for a reason which will be specified later, but it is part of the specific design behind this work. To identify the so-called disease-driven poverty traps. Think of this as the vicious loop that happens when a disease is both a cause and a consequence of poverty. And the feedback effects between disease and water resources. Given the waterborne nature of this disease, the building of dams and water networks, which are fundamental elements in poverty reduction, especially for Burkina Faso, they also do improve the diffusion of the disease, which means that we need to find out somehow the net effects between these two contrasting mechanisms. So why schistosomiasis and why schistosomiasis as economists? I mean, it's neglected, but it's very prevalent. It's more than 250 million people are still infected as of 2019. Has no vaccine. It is treatable, but reinfection is continuous. So having gotten it doesn't mean that we will not get it again. It's a debilitating disease, which is very important for the analysis that we will do with the effects that you can see in the slides. And in particular, the real burden is what is borne by children in terms of stunted growth, anemia, and cognitive deficits, which means that the long-term effects of this disease are widely considered to be labor impairing and poverty reinforcing, because especially in a developing country, having cognitive deficits at a young age will have, there's a long literature in economics of how this actually yields substantial economic impacts later on in life. Also, we look at this through sort of the economic eye, because the patterns, the way that this disease moves and is transmitted is closely related to man-made factors, the so-called anthropic factors. This map is taken from a Lancet paper of two of my co-authors, which is the mapping of the disease in Africa, and the white borders you can see is Burkina Faso. And we can see that the disease is indeed endemic throughout the African continent, and in particular in the sub-Saharan region, which you can see the red spots are the ones where the predicted prevalence is higher than 50%, so quite high, very high. So why Burkina Faso? First of all, because the disease is endemic. And second, in particular, it's because we believe that it is likely to constitute a baseline case for what is the worst possible burden from the economic perspective. Why? First of all, because its economy it's sensitive, it's vulnerable to diseases, and in particular to debilitating disease, since it's mostly consisting on subsistence agriculture, with the highest cash crop is cotton. Why also do we choose a particular country and not study something at a more aggregate perspective? Because we want to study this mechanism at the smallest possible scale we can, to really uncover and analyze deep mechanisms which happen, which can only be observed once we examine mechanisms, which means we have data at a small scale. And this is what we're going to do. We're actually going to study things at an individual level, at a household level. And this is a figure which is taken from the paper, which is what does the paper do in a nutshell? The first mechanism, number one, is this arrow you see, which is the effect that schistosomiasis has on agriculture, which uses a large data set that we create, which I'm going to discuss in a bit, which uses climate, land, plot, and household covariates. So natural covariates and man-made covariates, which is consistent with individual behavior and household composition. So this is the main mechanism, the burden, which is what schistosomiasis causes on agriculture. Now, because of the existence of aquatic snails, which are the main driver, which are the host, in fact, of the parasite, we use these snails to address a set of possible issues that could potentially invalidate our estimations, but particularly because we want to disentangle the connection between, as you well know, between correlation and causation. I will talk about this a bit more, but we will use the density of this intermediate host as instrumental variables, which is what is connected here. If you do causal inference, you recognize this as a direct acyclical graph. The other mechanism of interest is the connection with poverty. Once we establish the fact that schistosomiasis hurts agriculture, then we want to see whether the presence of poverty, which translates into, for example, less access to clean water, less access to healthcare, can actually increase the burden itself, thus generating a loop mechanism, also known as a trap. And the fourth is the presence of water resources. Water resources benefit agriculture, but also increase the suitability of the vector of snails, which means that we need to somehow net out these two effects to really find out what is the real benefit of having water resources in a country like Burkina Faso in Sahara, which is, of course, fundamental. So this is the paper. This is what's going to do the paper in a nutshell. I'll talk about the data because it's part of the contributions of the paper, which is matching and putting together different sources of data. The first is the survey data, which is the Enquête Permanente Agricole, EPA, collected in Ouagadougou. We had a collaborator in Ouagadougou who actually went to pick up these things. They were pre-existing, so already collected. These are large agricultural data sets which have data at a plot level, so at a plot, so at the smallest possible scale, with information of what is the crop, how much yield, inputs, pesticides, which is important to really uncover the mechanism and the effect that we want. We join this with individual, so household level survey data, which is household characteristics, demographics, age of the members, how many people work in a farm, how many families work in a farm, these kinds of things, and especially data on livestock. So what we do, we merge, we synchronize, and we geolocalize these villages. We cannot geolocalize the households, of course, for privacy reasons, but villages we can, which means that then we can actually have a clear identification of how these villages are located spatially, which then we join with the work done by my colleagues in Basel, which is the geostatisticians. So they map via Bayesian logistic models. They fit and they obtain high resolution estimates of the prevalence of schistosoma infection. There's a complicated paper. I do refer to the 2015 Lancet paper as well, to a more recent one. So basically you can see each one of these pixels in a figure is a measure of the prevalence of infection in school-age children, which then we translate into intensity with a procedure that's in the paper. Why is this important and why is this useful? Because this is a recent improvement in mapping, in disease mapping, because this allows us to join these data sets together and really see what the burden does at a household level. The last bit of data is the water resources. We also have a lot of data, of course, on climate, a lot of covariates, which we put into control for all possible confounding factors. This is a new data set that we have, which is, we put the 4 main dams of the country, which is the ones you see with the label here, which is Leri, Ziga, Bagre, and Compiègne. Mostly hydroelectrical with irrigation purposes, but aimed at cities and agglomerations. What is also important, though, that we have a special detailed data on medium to small reservoirs, which are the tiny triangles that you can see here in the figure. So basically what we do, we stack all of these layers together and we create a data set, which is what we use to fit our predictions, to study what, to test what our ideas are in terms of what is the impact of schistosomiasis, which we believe to be high, even though it's not been before now has not been explored in this sense, because again, it is a complex mechanism and this needs a lot of data, a wealth of data to address these complex answers. I will limit the equations of the paper to this one, but I think this is important to understand what's going on. So we identify the burden of the disease as a productivity shock, which is compatible with the debilitating nature of the disease. It is not a disease that kills, but it is a disease that does not allow populations to work as effectively as they should have. And this is reflected in our model. This model is yield, plot I, time T, household H in village J, which means think of this as the amount of cotton, the amount of maize, which is produced in a plot by household H. This depends on what? This depends on this function F, which is the technology, which means the way that all the inputs are put inside to create our output, which means in order to have agricultural output, you have seeds, you have pesticides, you have labor, you have manpower, which is everything that fits into this way, which fits in this function F, which we got an estimate. A is so-called the productivity, which means how well does a household use its impacts. And the new element of this paper is this element here. This is the disease. Phi is the burden of schistosomiasis, which means, and this exponent is negative, meaning that the higher is this number, the lower is the productivity of the household. Which intuitively also, if phi, which is the burden of schistosomiasis, is 0, then this doesn't matter. What does this mean? This means that our goal, the economic impact of schistosomiasis, is this parameter theta, which is going to be the goal of what we estimate throughout. Some little details. We use a variety of techniques to estimate this function F, which is by no means straightforward. The best way, we use adaptive methods or machine learning methods to absorb all the nonlinear effects due to the input matrix X. So this is the model we use to estimate. However, we need to again disentangle the relationship between correlation and causation and address potential endogeneity of the effect, and in particular the error in measurement of this variable. So we use the spatial density of the snails as instrumental variables. What are instrumental variables? If you not know, these are instrumental variable is a variable, an external variable, which is connected to the presence of the disease. So snails cause schistosomiasis, but it's very important that they do not directly affect outcome. They do not directly harm agricultural output. And this is, in fact, this is what they do. These are not snails that eat the yield, but just snails that lie in rivers, which means that these are good candidates for instrumental variables. Actually, these techniques are being used in recent times in medicine. For example, the Mendelian randomization is something that's used for, so the genetic traits are instruments. Whenever you have a clinical trial and you do not have perfect compliance in who is offered the treatment and who gets the treatment, the probability of getting treatment is an instrument as well. Or for example, there are studies in myocarditis and heart attacks, and they use the distance to the clinic as an instrument, just to put this into perspective in what's actually happening and why are we using these snails as instruments. Little details on how we do this. There's 2 forms of schistosomiasis caused by 2 kinds of parasites, Schistosoma mansoni and Schistosoma hematomium, so intestinal and urinary. Each one has a different snail host, the Bionfalaria fiferis snail and the Bulinus snail. So we need to account for this in a way. This is what we do in the paper. So we have this way of actually creating a measure which accounts for the prevalence of both snail and prevalence of parasite. There's more in the paper, of course. And these are the first results. This is the estimate of the parameter theta that I was telling. I would like you to focus only on the bottom one, which is, I mean, these are equivalent. These are not different, but this is the more refined estimation with the machine learning. So what does this mean? This means that this 6.6% is the loss, which is of yield. So how much loss, how much agricultural yield is lost by villages who experience, by households who experience the average amount of schistosomiasis intensity, which means average intensity villages and households lose on average 6.6% of yield, which is quite large. And in parentheses, it shows households which are at the top 5% infection clusters. So the ones that really suffer the most. They suffer an average loss of 32.2%, which is very high. Of course, these are not so many. This is just the ones at the top 5%, but it just shows how much, especially if you think about subsistence agriculture, how much this can have an impact just by itself. And so we estimate, and this is causal. This is really caused by schistosomiasis, which is the first result, which means that the effect is negative, is substantial, and is also nonlinear, as you can see in the bottom one, which shows that actually, the burden here starts to be negative around the upper 2 terciles of disease intensity. So whenever, in terms of policy, this is actually important. I will talk about this later. The second aspect is the cycle with poverty, because subsistence farming, you have to think of this as, shocking to income. Shocks to income are shocks. So whenever the income of a farming household of subsistence farming, which means basically, remember that this means that you farm to survive, which means shocking and reducing the amount that you can farm also affects your survival odds. So poverty is a consequence. Is it also a cause? This is the reason. First of all, we study our result in the paper is that the burden is almost entirely on subsistence crops. So that's the first sign. But the main result is that actually we focus on the bottom tail of the income distribution, meaning the households, the families that farm, and they are the 5% poorest. This is what we focus on. And we find that for these, the poorest ones also suffer a disproportionately higher burden of the disease. So just because you are in poverty, in a poverty state, so at the poorest income of joint crop weight and plot size, you suffer a 45% loss just because of schistosomiasis, compared to the 9.6 of all the rest. If we focus on the 10% tail, this is lower, but still substantially higher, 32.7 average loss, which means that not only does the disease cause poverty, it is also reinforced. The burden is also reinforced by the presence of poverty. So this is the first evidence towards this cycle of so-called poverty trap, which is important because especially this sheds light on the importance of controlling and addressing the problem of schistosomiasis. The last bit is going to be the connection with water resources. This is the same figure you've seen earlier. So this is done at a village level because of a variety of reasons. We study two different things. First is the impact of the first of the 4 main dams, 1, 2, 3, 4, the ones you see with the label in the figure here. And then we refine this a bit and we study the impact of distance. So how far is a village from a dam? Just a tiny detail. Now we account for spatial correlation because it turns out we need to. So we actually have something a bit more sophisticated, which is, of course, if there's more to this if you would like. So this is the result. I'm going to explain this with a bit of detail because it might be a bit confusing. Focus on the first panel. And the first panel tells you what? It tells you that the effect of the dam, so a village which is on a radius of 30 kilometers within a large dam, experiences a beneficial effect just because of the dam of 24%, which is understandable because, of course, it cannot be otherwise. Dams have a beneficial effect, and this effect is represented here. However, these villages which are within this radius of this large dam, which I remind you, it also increases the spatial prevalence of the snails, which also increases the prevalence of schistosomiasis. It also causes an increased burden, which is 13.6%, which means that the real effect of the dams, the real benefit of the dams, it is not 23.9, it is in fact 23.9 minus 13.6, because it does not account plus 3.7. We need to account for the fact that not only there is a beneficial effect, but there is also a counteracting effect, which is the increase of burden due to schistosomiasis. And this is the first result, which is a bit disheartening. Something which is a bit more heartening is that do all dams affect the burden of schistosomiasis alike? The answer is fortunately no. Think of it this way. This effect on the left is the burden which is experienced by a village which is within 1 kilometer of a large dam, which is 20%, very large. This on the right, plus 1.5, it means that the further away a village is from the dam, the more the burden is reduced. In other words, being further away from dams is beneficial, which means that the distance does have a substantial effect. The good part of this is that distance from a water reservoir, which is not one of these large dams, does not seem to have a negative effect. So that's good, I guess, which also has a lot of important policy perspectives I will talk about briefly. For time, we're doing well. So, so what are the implications? What is the policy relevance and what's really going on now with the paper? So what we find, our results, first of all, imply an estimated loss of 0.8% of Burkina Faso GDP, which is substantial. Think of it, it's just because of the disease. It's not a small number at all. It might seem small, well, not even 1%, but 1% of GDP, 0.10% of GDP is a lot. And especially considering the fact that this is concentrated and the burden is really on the poorest, which also means the most vulnerable, which is also, again, augmented and amplified by the presence of poverty. So this has an implication also in terms of inequality, which is a bit of a finer point, so to say, which means that think about the fact that the large infrastructure, so the large dams, these are not built for the villages around. They're built for a hydroelectrical purpose. They do have some spillover benefit, but they are really concentrated on hydroelectrics, which means for larger cities, which means from an inequality perspective, the households and villages around, which we have shown that actually do suffer a substantial increase in schistosomiasis burden, are not the ones that actually draw the real benefits from these large water infrastructures. So this is something that needs to be considered. And this also translates directly to what the policy sort of implications of our work are, which is, first of all, is that the burden seems to be at the upper 2 terciles of disease intensity, which means, of course, if one could control everything simultaneously and go throughout the whole country equally, that's great. We've seen that actually the average impact is substantial. So the more controlled, the more disease control, the more we can go towards disease eradication, the better. However, the existence of budget constraints, the existence of finite amounts of money that can actually be used for these interventions, which are very costly, allow that the real economic burden really must be concentrated in the parts that suffer the upper 2 terciles of this disease intensity. This is a first sort of important policy recommendation, that take home policy from this. And given that the nature of this burden, we've shown this to be poverty reinforcing. So again, it is cause and consequence of poverty, which means that intervening in rural areas, which are, of course, in sub-Saharan Africa, which is also, by the way, where most of the disease is concentrated in Africa, they can really go a long way. And intervening in these places can really go a long way in terms of both, improving of quality of life, but also survival odds, really, which is not, because the disease itself is not life-threatening, but the consequences, the economic consequences of the disease in a country like Burkina Faso or other countries surrounding, which are kind of similar, can actually have life-threatening consequences in terms of harming the survival odds of the population. And also we see that switching farmers away from subsistence crops can actually have an added benefit. It's always a good thing to do. So shifting, I'm not saying it's just because of schistosomiasis, shifting populations away from subsistence has a sway of possible beneficial consequences, but this is one of them, which is not usually considered. And the last is the fact that large dams, so they are a substantial part of developmental finance. So the recommendation would be to instead focus on reinforcing small to middle-sized irrigation networks instead of shoving in substantial amounts of money to build yet another very large project, which seems to have reduced returns than what it might actually show if one does not consider a wider set of environmental, economic, and public health externalities. So a little bit about future extensions. I mean, first of all, as Dr. Ingalls was mentioning before, this can be extended to other diseases. It's a new framework to using high definition disease maps. It's data hungry because this needs a lot of data. You cannot always find these kinds of data sets. But if you do, this allows to really explore the complex mechanisms at play, which we've only seen a small fraction of this massive iceberg, which is this complex topic, which is the connection between infectious diseases and economic systems, and particularly if one studies poverty and inequality. So with a lot of complicated mechanisms underneath. We are actually working at the moment with malaria. There's more data with this, but there's a lot of work that can still be done by studying this approach at a smaller level. There's a new paper on the way, which has a more theoretical approach, but other extensions that can be put are more on the economic side, which is labor frictions, market failure, climate catastrophes is very important, but in particular, the role of labor migration, which is known to actually spread schistosomiasis. So that's it for the paper. And so basically what have we done here? Using Burkina Faso to study how schistosomiasis has a large negative causal and non-linear effect. And it is a productivity shock. It causes an effect which is akin to a poverty trap, and it causes substantial feedback effects between disease diffusion, economic burden, and water resources development. And that's it for me. Thank you so much.
Okay, thank you much, Dr. Daniel. Very interesting and very complicated research work. And from your speech, we can show that too much data was involved in the studies, and so as very interesting results. And yes, we also have the similar conclusions with schistosomiasis research. So from these studies, we also see the recommendations from for the policymakers, and very good work. Thank you very much. So next step, let's invite Professor Xiaonong Zhou to comment on the conference. Professor Zhou is the director of the National Institute of Parasitic Diseases, China CDC, Chinese Center for Tropical Disease Research, One Health Center, Shanghai Jiaotong University, the University of Edinburgh. So as Professor Zhou speaking, you can enter the questions in the chat window. We will discuss it later. Okay, Professor Zhou, please.
You're muted. You are muted, sorry.
Time for our meet each other for those old friends. And now we are also look forward to see more new friends to come into our idea forum. And today, I'm very happy to see Dr. Daniel Rinaldo to give our very interesting talk on the economic impact of schistosomiasis, study design and data. So this is really important for our estimated economic impact of schistosomiasis in Burkina Faso, why its impact on the agriculture production. And they created an original data set that combines detailed household and agriculture surveys with high resolution geostatistical disease maps. They developed new methods that used for the densities of the intermediate host snails of schistosomiasis as the instrumental variables, together with the panel, spatial and machine learning techniques. They found the very interesting results that the elimination of schistosomiasis in Burkina Faso would increase the average crop yield by around 7%, raised to the 32% for high infection crust. So thanks one guest to the Dr. Daniele Rinaldo from the University of Exeter, UK, to give so interesting talk, and we hope to receive those similar interesting paper in the future for our infectious disease of poverty. As the editor-in-chief of the infectious disease of poverty, we designed this idea forum to focus on the produce the new ideas, produce a new design, produce the good editing results, and produce the good articles for all the audience to engage the scientific community and advance the research findings in the future. Also, it is one to share our authors' research findings and stories, enabling their interaction with the audience and the readers. So we are very happy to organize the previous 5 sessions as the right. So today, this is the 5th one, also very successful. Thanks to Dr. Daniele Rinaldo once again. As the previous 4 idea forum, I would like to give you an overview a little bit, because the first one, we focus on the global response to the local poverty-related disease priorities, which tell us how to get the research work focused on the poverty-related disease. The second one, we focus on the COVID-19 research mathematical modeling, which really help us to understanding transmission pattern through the modeling work. And the third one, we also developed the sustainable financing model for effective TB service delivery system in China, which is one of outcomes from the Gates Foundation granted projects which happened in China. So this also give a good model to the world how to effectively to improve our TB services delivery system. The fourth one, we focus once again on the COVID-19 relevant study design, research methodology, and then results implementation. And this is really important for our journal, since we are already editing 4 special issues focused on the COVID-19. So welcome good paper and good results from all the audience on the COVID-19, since this is a pandemic disease and it's still around us. And I also would like to look back all the year in 2021, what we have achieved for the infectious disease of poverty. So we got the more than 800 submissions and published only 1/3 of it, a total of 137 publications was published in our journal. And those publications actually covered 56 countries. For the submission, actually covers the 75 countries. And all those papers, published papers, had a very good impact, because we got the more than 1.8 million downloads and more than 4,500 citations during last year. And we are very happy to see our impact factor has increased to the 4.38 in the June last year. And it's also equivalent to the site score at the 7.2. So by this chance, I also would like to thank to those active reviews to help our journal to keep the high quality of the journal. So The first 10 top reviews was that Dr. Zhou Yibiao, Dr. Li Lingshu, and Dr. Temple Ernest, Dr. Zhang Shengxin, Dr. Wang Wei, Dr. Robert Berquist, Dr. Talupo Atalobi, Dr. Che Kun Fang, and Dr. Li Ying, and Dr. Hassan L. McAfee. All those reviews have very good contribution to our journal reviews in the last year. So we hope more good reviews coming and to help our journal to improve our impact in the future. Thank you once again for all the audience today, and also thanks all the authors and the readers and the reviews to support our journal to give the more great impact to the control program for the infectious disease of poverty. Thank you once again.
Okay, thank you, Professor Zhou.
Ladies and gentlemen, good morning, good afternoon.
Okay, thank you much, Professor Zhou. Now let us look at the question proposed by the audience for the Dr. Daniel. Is there any questions?
Yes, please.
This is a very good case study about the economic impact on the NTDs, such as schistosomiasis. So I think there must be some questions about this topic. Their codes and the data in the article already open resource. Is this question?
So the data and the code. So the problem is that the data, the raw data itself is not public. So the climate and everything and the maps are open source. In fact, they have come from the Lancet paper in 2015 by my co-authors, and I'm sure they will send the data over for the disease at request. The survey data is not. Because this is something that we had to obtain. This was part of a grant that we had, and someone who was in Ouagadougou talking to people and getting it. So it was not the easiest thing in the world. What is, though, on my GitHub page, you can find it on the paper, is the data that I have used for the paper is available, but not the raw survey data sets, which went through a lot of process, because these are not public. And these need approval from the Institute of the Demographic and Statistic in Ouagadougou. Everything that is used for the paper is available on my GitHub page. So, if you
okay, thank you. Just it is a very good case study. So maybe there are two questions about this. So the first one is water source affects the breeding of the snails and also the yield of the crops. How does your article quantify the impact of each crop on snails, either directly or indirectly through water? Okay. Water resource effect.
This is something that we control about. And particularly we control about snails, we control about, it's called the crop and household fixed effects, which account for this, and time fixed effects in particular. But this is part of the description of the paper, but we use lag snails to exactly avoid simultaneous dependence on this. So snails at year t-1 as an instrument for disease at time t. But great question. It's very important because this can invalidate, but this is something, of course, we have to deal with.
Yeah, and one more thing, the farming is cyclical. The farming is the cyclical. And the snail transmission also shows seasonally. So how you combine this time difference in your model? Yeah, the farming cycle and the snail transmission also show the time difference. So how do you combine? How do you combine them?
Well, we have yearly data, so the within year transmission is not represented. We have the average, I guess, throughout the year. So seasonality is not included. In terms of farming cyclical through the different years, we have 2 years, and we account for different crops. And again, we absorb for all kinds of unobservables by means of crop and time and interacted crop and time fixed effects to exactly account for this. Again, this is not something, we're not interested in the seasonality itself, but to absorb the effect of seasonality. So yeah, fixed effects, time, crop, household, and interacted each one of these as well.
Okay, so the last one is I think for your data about the prevalence of the schistosomiasis. So in your presentation, you showed your prevalence of the schistosomiasis on the in the school children. So this question is it enough for the model only the prevalence of the school children? Is there any other populations such as adults?
So we don't have data on the adults because the mapping is done for the prevalence in the children, and so we have to work with what we have. But I can be a bit more sort of convincing than that, is that really the burden is borne by children. So whenever you have stunted growth in children, this is what is reflected in, let's say, the stuntedness, the real long-term damage in terms of productivity, in many terms, but from our perspective of labor productivity, is when you're exposed to these negative effects as a child.
Yeah. Okay. Thank you very much. So, okay. So now we have this forum. I think is now is to over time. So is there any questions now, Dr. Jean?
One on the machine learning. You sent me one on the machine learning embedded in the model. So the way machine learning is used is it's not connected to the schistosomiasis, but in fact it's complementary to schistosomiasis. It's not logistic, it's regression. So basically it's called double machine learning. We use machine learning to explain all the nonlinear effects from inputs from yield as well as from schistosomiasis. Actually, and to snails as well, because then this translates into an instrumental variable. It's a way to absorb non-specified, so data-driven nonlinear effects from the inputs into this. Partial them out, absorb this, and then have a clearer idea of the connection between yield and disease.
Okay. Thank you very much. So it's time for the forum over. And is there any close remarks, Dr. Jean?
No more remarks, no more comments, no more questions.
Okay, so thank you very much, Dr. Daniel. Gave us very excellent presentation. So we hope to cooperation with you next time. Okay, thank you very much. So this time, okay, thank you. Yes, it's time for the forum. Okay, let's close the forum. So see you later. See you next time. Okay. Thank you.